What's going on, guys? My name is Matt, and a few weeks back, the sponsors of today's video, Intel and Corsair, challenged me to put together a gaming PC more powerful than any I've built in the past. This system is not only featuring the latest and greatest i9 CPU and RTX graphics, but it's also completely custom water-cooled featuring Corsair HydroX components. This is a seriously epic build that I am excited to show off to you, and I again want to thank Intel and Corsair for making this video possible. Now, not only does this build look amazing, but it can play pretty much any game at 4K ultra settings with 60+ FPS. When going into a build like this, it's important to do as much planning as possible to make sure the end result is exactly to your liking. For the core components, that was pretty easy to figure out, but for the water cooling components, I used the HydroX configurator to make sure I was getting all the correct blocks, fittings, and other components that I would need. So now that you have a base understanding of the system, let's go ahead and get into the parts that make up this $3,500 gaming beast. At the heart of this build is the new Intel Core i9-11900K. This is Intel's latest and greatest flagship gaming CPU. It's one of the best gaming CPUs available, and in games like Watch Dogs Legion and Borderlands 3, it actually outperforms every other processor on the market. This is an 8-core, 16-thread CPU running on the Rocket Lake architecture. It has a base clock of 3.5 GHz and a single core boost clock of 5.3 GHz. With some tuning, we can actually get it to run at around 5 GHz indefinitely. Now, doing that does require a lot of cooling headroom, which is helped by the custom loop, which I'll talk about more later in the video. With an 8-core CPU like this 11900K, you not only can game, but streaming and video editing are both handled with ease. Intel actually recently released a full range of 11th gen CPUs, and to find out more, head to the link in the description. For the motherboard this is going into, I went with the Asus ROG Strix Z590-A Gaming Wi-Fi. This is a really nice board with a lot of great features like 3M.2 slots, 11 back panel USB ports, and a robust VRM configuration. It uses a black, silver, and white color scheme, which works well with this build in my opinion. This is a relatively expensive motherboard at around $330, especially compared to the boards I usually work with, but for a high-end build like this, I think it's a great fit. For RAM, I decided to go above the 16GB I usually get for gaming builds, and went and put in 4 8GB sticks for a total of 32GB of RAM. 32GB is a bit overkill for gaming, but again, with a system this powerful, it makes sense. The specific RAM kit I went with is the Corsair Vengeance Pro SL in white. Again, this is a 4x8GB kit, and it's rated to run at 3200 MHz. This fits perfectly into the build, and the lighting it has is the best I've personally seen on a RAM kit. It's bright and integrates seamlessly with all the other components using the Corsair iQ software. The white colored dims look great, and there's something super satisfying about filling all 4 of the RAM slots. This means upgrading won't be as easy as it would be with a 2-stick kit, but unless you get into something like heavy video editing, then 32GB should last you for years to come. In terms of storage, this system is using a 1TB Gen 4 NVMe SSD from Corsair. This is the Corsair MP600 core, and it's positioned as a mid-range drive in Corsair's Gen 4 NVMe lineup. Its performance is amazing, and at around $150, it's a fairly good value considering how well it performs. With sequential reads and writes rated at 4.7 and 1.95 GB per second respectively, the MP600 core works amazingly as a boot drive, or could even be used as a scratch disk for video editing. It has an integrated heatsink, which I opted to use over the Asus motherboard one, just because I trust Corsair's heatsink designed specifically for the drive versus the motherboard one. With that being said, it would be interesting to see if there's a performance difference between the two. 1TB is plenty for your OS, applications, and a good number of games, but it wouldn't be a bad idea to add some extra storage out of the gate. With a high-end system like this, adding a cheap 2TB SATA DRAM-less SSD would be a good option, or even a few large-capacity mechanical drives depending on your storage needs. For the graphics card, I went with the best card I could get my hands on, which is the RTX 3080 from PNY. This card is using the reference PCB and has a decent cooler pre-installed. The 3080 is not the best card on the market, but it's one step down from the 3090 and still provides mind-blowing performance at 1440p and 4K resolution. It has 10GB of video memory, and unlike the Founders Edition, this version just uses standard PCIe power connectors. I'm definitely aware these cards are very hard to come by right now, but hopefully the shortages will improve in a few months. With such power-hungry components, the system needs a high-quality PSU with plenty of wattage. What I went with is the Corsair RM1000X. As the name implies, this unit is capable of outputting 1000 watts, which is more than enough for this system even when overclocked. It's 80 plus gold rated and uses a fully modular design with all black sleeve cables. With 100% Japanese capacitors and Corsair's 10-year warranty, I feel very safe using this unit in such a high-end build. Next, let's talk about the case. What I went with is the Corsair 5000D Airflow. This is technically a mid-tower case, but it's definitely on the bigger end of mid-tower cases, and that's a good thing because of how much room it has for water cooling. This chassis is seriously well thought out. The panels come off super easy, there's fan filters everywhere, room for up to 10 case fans, and the list goes on. I really like this case because of the attention to detail. Matching different white parts together is not easy, and usually white plastic and white metal in cases end up having noticeably different hues, but in this case the color is perfectly matched. Another great example of attention to detail is this removable section of the power supply shroud, which can be replaced with this piece to give more room for water cooling, but still allowing the build to look super clean. It's all white except for some gray accents. The front panel I/O is solid with a power and reset button, USB 3 Type A, USB-C, and a headphone mic combo port. Overall, this case is really awesome and I can highly recommend it for your next high-end PC build. Finally, let's talk about the cooling system. This PC is tricked out with a fully custom loop using softline tubing. All the water cooling components are made by Corsair and are part of their Hydro X series. In terms of the setup, I'm using a white XC7 block for the CPU and the XG7 block for the GPU. The XD5 pump res combo uses a high quality D5 pump, and just like the CPU and GPU blocks, it has RGB lighting integrated into it. For radiators, I went for dual 360mm white radiators, and each of these has 3 LL120 fans on them. These parts in combination with white/silver fittings and softline tubing make up a pretty awesome loop that looks and performs amazingly. These white Corsair Hydro X components look super clean, and I actually may switch this to hardline tubing in the future. Corsair has new frosted hardline tubing that would look awesome in this all-white build. It would be cool if Corsair would release white versions of their GPU blocks, but the black one looks fine in this build. Another small thing I added was some white cable extensions for the 24-pin PCIe power connector. In terms of the building process, this went pretty smoothly. The 5000D Airflow gives a lot of options, even giving you the option to place fans and radiators on the side, which I opted to keep the side shroud on, but I have seen some awesome builds utilizing a radiator on the side mount along with more fans at the front. After planning everything out, I started putting in components, which stuff like this removable front mount made very simple. Once all the components were in, I could start adding fittings and tubing. Softline tubing uses what are called compression fittings. You unscrew this top piece, slip it over the tube, press the end of the tubing over the barb, and then screw down the top piece, leaving you with a super secure connection. There's a lot more room for error with softline tubing, and I would just hold it up to the run I wanted to make, cut the piece, and attach it with fittings at both ends. I've only done one other custom loop, which was actually another Hydro X build in a sleeper case using hardline tubing. Softline is definitely easier, but I don't think that hardline is that much more difficult, especially if you're willing to get extra fittings to avoid a bunch of multi-bend runs. The only problem I ran into was actually my fault. As I was filling the loop, I didn't realize one of the caps was not on the reservoir and water started to spill out into the bottom of the case. With that cleaned up, I started to fill up the system, turned the pump on for a second to circulate some water, add more water, and repeated until the loop was full. Once all closed up, I tipped the PC in a bunch of different angles, making sure the inlet to the pump always had water going into it. This allowed bubbles to get out of the loop, which can help performance. I then let the pump run with nothing else powered on for about 24 hours to get more bubbles out and to ensure there weren't any leaks. Once I knew everything was good to go, I went ahead and powered it on for the first time, and I was amazed at how good it looked with all of the lighting. The default rainbow looks like this, but I ended up going for an all-white look that I think looks amazing with the all-white components. One big plus of using all these Corsair components is all the lighting is easily synced in IQ, and you can even control stuff like the pump speed and monitor temps all within this one program. With it all up and running, I first wanted to get into Windows and make sure everything was working okay before doing any sort of overclocking or BIOS tweaking. After that, I headed into the BIOS to change a few settings. The first was enabling the XMP profile for my RAM. Then under the multi-core enhancement, I set it to enabled, remove all limits, and then enabled Asus's AI tuning under CPU core ratio. I'm not an expert overclocker, and these options get very close to even what some seasoned overclockers can get. With these changes made, I hopped into Windows, made sure everything was stable, then went to overclock my graphics card. I did a very basic overclock, increasing the power limit, increasing the core clock by around 70 MHz, and increasing the memory clock by around 400 MHz. I'm sure a bigger overclock could be achieved, but I was on a tight timeline for this project and will eventually go back and tweak things for max performance. With all that done, I was ready to hop into some games and start testing. I tested all these games at 1440p and 4K along with some other synthetic benchmarks. To start things off, let's talk about COD Warzone. This is a popular game that's pretty difficult to run, but unsurprisingly, the system absolutely crushes it. At 1440p with most settings maxed out and no ray tracing, the system put out a 148 FPS average with 1% lows of 103. This is amazing to see that you can play a game like Warzone at 1440p, 144Hz with very high settings. Moving up to 4K, we did see a dip in performance with a 94 FPS average and 70 for the 1% lows, but I still think that performance is great considering this was being played at 4K resolution. Next up is Borderlands 3. I used the built-in benchmark at the Ultra preset. At 1440p, the system put out a 116 FPS average with 1% lows of 84, and at 4K it produced a 65 FPS average with 1% lows of 52. This shows that even AAA games at Ultra settings can be played at 60 plus FPS on the system, which is really impressive. Next, I tested Fortnite at max settings with DLSS turned off. Now, obviously most people play this game at much lower than max settings, but even with everything turned up, performance was great. At 1440p, the system put out an overall average of 175 FPS with 1% lows of 81. At 4K, the system averaged 94 FPS with 1% lows of 67, which again is pretty good performance in my opinion. Moving on to Shadow of the Tomb Raider, I test this game at the highest preset with the built-in benchmark. Doing this at 1440p resulted in a 146 FPS average and 1% lows of 85, and at 4K it resulted in a 82 FPS average with 1% lows of 65. Next is an esports title, Rainbow Six Siege. I tested this game at Ultra using the built-in benchmark, and performance as expected was insane. At 1440p, the system put out a 442 FPS average with 1% lows of 364, and at 4K the system averaged 271 FPS with 1% lows of 232. As you can see, this system is super overkill for a game like Rainbow Six, but it was fun seeing how high the frame rates would get with this system. Finally, I tested Doom Eternal at Ultra settings in the campaign. At 1440p, the FPS during intense combat stayed in the low 200s, and at 4K stayed in the 130 to 140 range. As you can see from these gaming benchmarks, the system's great for 1440p 144Hz gaming and 4K 60 plus FPS gaming. This is an incredible experience, and if there are other games you'd like to see me run on this, let me know, as I may make other videos about this system. The final benchmark I'd like to talk about is Cinebench R23, just to show how powerful this CPU is. The i9-11900K produced a multi-core score of 15,576 and a single-core score of 1645. During the Cinebench run, the CPU was staying around 5 GHz on all cores thanks to the AI overclocking, and the temps were in the upper 80s most of these runs. In terms of temps while gaming, the CPU had a range of temps from 66 up to 80 degrees, and the GPU stayed in the range of 53 to 59, and these numbers are the range of all the games tested, but you can look at the benchmarks for specific temps in specific games. Seeing as both of these components are overclocked, I think these temps are fine. Overall, the combination of the 11900K and the 3080 provides mind-blowing gaming performance, and using the fully custom HydroX loop allowed temps to stay in check even when overclocked. I'm super happy with how this build turned out, but let me know what you guys think in the comments below. So yeah guys, I think we've reached the end of the video. Thanks again to Corsair and Intel for sponsoring this video. I'll have links to all these parts in the description, so make sure to check them out. If you guys enjoyed the video, give it a thumbs up and consider subscribing, and as always, this is Matt from Tech by Matt, signing out.